Hello, ladies and gentlemen, my 8th grade physical science kids. Mr. Hescock's back again talking about matter and what we're going to talk about phase changes in matter today. Before we can do phase changes, you have to remember what the phases of matter are, or the states of matter. Solid, particles are moving slow, they're in fixed positions. Liquids, they're moving a little bit faster, the particles, and they are able to slide past each other. And gases, where they're bouncing all around. If you were in certain high energy states, you could have said plasma as a fourth state. So we're going to talk about phase changes today, and I have a little review at the end. Changes of state are physical changes, meaning it doesn't change the substance, it only changes the shape or phase that it is in. Matter can change from one form to another. When matter changes from a solid to a liquid and to a gas, it doesn't change the substance. On a cool morning, the grass has dew on it. Well, dew is not necessarily rain, it is actually condensation of water vapor in the air. So let's talk some more about this. The solids can become liquids and liquids can become solids. Melting is a process by which a solid becomes a liquid. Over here you see a ice cube slowly melting. The melting point is the lowest temperature at which a substance begins to melt. The melting point of water is 0. The freezing point of water is 0. They're actually the same number. It purely depends on if you're removing energy or if you're adding energy to it, whether it freezes or melts. At melting point, the solid particles begin to vibrate fast enough that they are now able to slide past each other. They are no longer fixed in a certain place. Melting points are very specific to each material and sometimes used to identify unknown materials. Freezing. Freezing is the opposite of melting, the process by which a liquid becomes a solid by usually removing heat. As particles lose heat, they slow down until they reach a point that they cannot slide past each other. The freezing point is the temperature at which a liquid becomes a solid. Now for water, it's 0, but for things like iron, it's like over 1,000 degrees. So iron freezes at a very high temperature. The freezing point of a substance and its melting point are the same. It simply depends on whether you are adding energy or removing energy from that magic point. Liquids can change to gases, and gases can change to liquids. Evaporation is a process by which a liquid becomes a gas. We've all seen puddles that dried up in your yard. In fact, this year it's been really dry this summer. There are puddles that I know of in the woods that were wet for years that are completely dry right now. They've evaporated all the water off. As the particles move apart, they break apart and spread away from the liquid. Evaporation generally occurs at the surface of the liquid. So the larger the surface area, the more evaporation. So lakes evaporate a lot of water. Oceans are where we get most of the water vapor on Earth. By having that surface of the liquid, that's where those particles are going to break apart and travel out into the atmosphere. The warmer the water, the faster those particles are moving, the faster it will evaporate. So if it was a 35-degree day, those puddles are going to take a lot longer than when it's 80 degrees to dry up. A shallow puddle with a very large surface area to volume is going to dry up by far the fastest. This is heat speeding up particles, which we call boiling. So this is your steam here coming out of this coffee pot, and this is heat causing the water to boil. Evaporation and boiling are slightly different because boiling, we're actually adding heat. Evaporation is it happening on its own because of the particles just escaping. When we force the particles to speed up by adding heat, we call that boiling. Can a solid change to a gas? Absolutely, but only for certain things. The most common one is for dry ice. If you go out west and shoot an elk, they'll pack it in dry ice to bring it home. Well, the ice is not ice as you think about it. This is frozen carbon dioxide. Frozen carbon dioxide does not melt into a liquid first. There's no liquid carbon dioxide. It goes straight from the solid form of dry ice to the gas form, and you can see the vapors of the gas here. This is carbon dioxide gas coming off of this piece of dry ice here in this pot. Regular ice can sublimate. I could not get my 80-year-old grandmother to understand for years and years and years that her refrigerator was not eating the ice cubes that she didn't use. Over time, regular ice can sublimate in the freezer as air hits it. A little bit of that ice can go away. And she was convinced that her freezer was eating the ice cubes. And I tried to explain to her no, that water in the form of ice can sublimate very slowly, unlike regular dry ice that does it very quickly. As we boil things, the liquid is changed. You add boiling points are very useful in determining the type of substance you're using and actually separating them out. You can do something called distillation that we'll talk about shortly. Boiling point is the temperature at which a certain liquid boils. The boiling point of water is 100 degrees Celsius. That is 212 degrees Fahrenheit. Different air pressures can cause the boiling points to change. The higher the air pressure, the higher the boiling point. The lower the air pressure, the lower the boiling point. If you go to the top of a mountain, a very high mountain, it'll actually boil at 97, 96 degrees Celsius, whereas at 100 degrees Celsius, you need to be at sea level. Changing a gas to a liquid, we call this condensation. Many, many times I've had an ice cold drink in the summer and your glass gets very, very wet with droplets of water all over the outside of it. This is because that cold energy actually absorbs some of the energy of the water droplets in the air, causing them to condense. It's like when you make Campbell's soup. That is a condensed soup. They've actually caused the particles to be squozen together. As particles of a gas cool, they lose their speed and begin to condense and stick back together. Dew, condensation, clouds, fog in the air are all examples of condensation. Let's see what you remember. What phase is in each picture, or what phase change? Here you have a cloud. A cloud is a gas, so you could tell me that. Or you could tell me that that is condensation. Here's a puddle. What will happen in our puddle? The puddle is liquid, but it's going to evaporate. Here's ice cubes. They are solid. Here's ice cubes melting. That is melting. This could be gold or this could be iron being poured into bars. That's also melting. This is dew on a blade of grass, so that is condensation. This is Old Faithful. Old Faithful actually erupts because of the hot magma chambers down underneath the ground, causing the water to boil into steam. So that would be boiling, or you could tell me that this is steam. And just for fun, that's just Ice Cube telling you, let's go to work. Speaking of going to work, make sure you do your reading in the review for Chapter 2, Section 2. I'm Mr. Hescox. Until next time, be good, stay safe. See you then.